Alright, hi. Subcourse AL0907, Edition A, Basic Hydraulic Pumping, Army Institute Professional Development. Lesson 1, Basic Hydraulics, STB Task 55175811071. Introduction. Hydraulics has been proven the most efficient economical system adopted by aviation. First, the ancient Greeks means the elevating stages of amphitheaters for principal hydraulics were explained scientifically as the 17th century scholars Pascal and Boyle laws have discovered the two men regarding the effect of the pressure, temperature, fluids, gases, and confined with air, the basis of principal mechanical advantage, in other words, why or and how of hydraulics. This chapter explains the basic application for the hydraulics in Army aviation with the characteristics of these systems. The explanations include a detailed definition of terminology, particularly with the hydraulics, where you must be familiar to understand with the subject. Aviation hydraulic heat for the fluids under the pressure transmit force development in one location on the aircraft and other related equipment to some other portion of the aircraft with equipment. Hydraulics are included with the principle underlying hydraulic action and the methods of fluid equipment used in implementing those principles. Hydraulic and hydraulic. The word hydraulic is derived from two Greek words meaning hydro, meaning liquid or water, alus, meaning pipe and tubing. So you have hydraulic. Therefore, objectively implying with the word minifies the sum of the major way confined with the liquids. Example that can be found in everyday use of the hydraulic in connection with the familiar items such as automobile jacks and brakes. As further example, the phrase is hydraulic freight elevator refers to the elevator extending and descending on the column liquid instead of using cables and a drum. On the other hand, the word hydraulic, generic name of the subject, according to the dictionary, hydraulics is defined as the branch of service or branch of science that deals with practical applications such as the transmission of energy or the effects of flow of a liquid in motion. Use of hydraulics in Army aircraft. One of the fixed-wing aircraft hydraulics used to operate retractable landing gear and wheel brakes to control the wing flaps, propeller pitch in conjunction with gases. Hydraulic is used in the operation of rotary and wheel brakes, shock struts, shimmy dampers, flight control systems, floating ramps, folding pylons, winch hoists. Characteristics of hydraulic system. Hydraulic system have many desirable features. However, the one disadvantage of the original high cost of the various components is this is more offset many of the advantages of the hydraulic system with the most economical means of power and transmission. The following paragraph discusses some of the advantages of the hydraulic system. Efficiency. Discounting any losses of that can occur with the mechanical linkage. Practically, with the energy transmitted through the hydraulic system is received and output, and where work would be is performed. The electrical system is closest to the competitor is 15% to 30% lower efficiency. The best straight mechanical systems are generally 30% to 70% less efficient than comparable hydraulic system because of the high inherent factors, friction losses, and inherent is the resistance to motion, action, or change. Dependability. The hydraulic system is consistently reliable. Unlike the other system mentioned, is not subject to the change of the performance of suspect and sudden unexpected failure. Control sensitivity. The confined liquid of the hydraulic system operates like a bar of steel transmitting the force. However, the moving of the parts of lightweight can be almost instantaneous. Put in the motion and stop. The valves and with the system can start with the stop of the flow of the pressurized fluids almost instantaneously. Require very little effort manipulating. The entire system is very responsive to operator control. Flexibility installation. Hydraulic lines can be run almost anywhere. Unlike mechanical systems, the most flow of the straight path lines of the hydraulic system can be led around obstruction of the major components of the hydraulic system. With the exemption of the power-driven pumps located with the power source can be installed with a variety of places. The advantage of the feature is readily recognized when you study the many locations of hydraulic components in various types of aircraft. Lower space requirement. The functional parts of the hydraulic system in all small comparison to those other systems. Therefore, the total space requirement is comparatively low. These components can be readily connected by lines of length and contour. They separated and installed small, used out of space wide and large unoccupied areas for the hydraulic system unnecessary and short special spaces requirements are reduced to a minimum. Low weight. The hydraulic system weighs remarkably little in comparison to the amount of the work it does. The mechanical and electrical system capable of doing the same weight and considerably more. Since non-payload weight is an important factor for the aircraft, the hydraulic system is ideal for aviation use. Self-lubricating. The majority of the parts of the hydraulic system operate in a bath of oil. Thus, the hydraulic system is practically self-lubricating. The few components that do require periodic lubrication, the mechanical linkage of the system. Low maintenance requirements. Maintenance records consistently show the adjusted maintenance repairs as part of the hydraulic system with the seldom necessary. The aircraft time and change schedule will specify the requirements for the component on the basis of hours and flow. flown days elapse and require relatively infrequent change of the hydraulic components. Fourth, the word force used in the mechanical sense means that the push-or-pull force becomes it is the push-or-pull tends to cause the object which is exerted in the move. In certain instances, when the force is acting on the object is not sufficient to overcome the resistance drag, no movement and will take place in such cases that will force it will still considered to be present. Direction of force. Force can be exerted in any direction. It may be act downward, which as when gravity acts on a body pulling it towards the earth, the force may come across it. When the wind pushes the boat across the water, the force can be applied upwards, as well as an athlete throws pushes or a ball into the air or forces, and it can be acted in all directions at once, as when a firecracker explodes. Magnitude of force. The extent of the magnitude of the given force is expressed by the means with a single measurement in the United States. The pound and the unit measurement force. For example, this took 7.5 million pounds to thrust to lift the Apollo moon ship off its launch pad. Hydraulic force is measured with the amount of the pounds required to display an object within the specified areas, such as in square inch. Pressure. The word pressure, when used with the conjunction mechanical hydromechanical system, the two different uses, the one technical, other non-technical. These two uses can be easily distinguished from either the presence or absence of a number. In techniques, the number always accompanies the word pressure. In non-technical use, no number is present. These definitions are further explained in the following paragraphs. Technically, the number accompanies the pressure conveys the specific information about the significant strength of the force being applied. The strength of the applied force is expressed with the rate at which the force is distributed over the area on which the acting, thus pounds per square inch. Express rate of the pressure just miles per hour does the speed. Example of this is hydraulic system of the UH-1 aircraft functions at 1500 psi. Non-technical. The word pressure, when used with the non-technical sense, simply indicates the unspecified amount of force is being applied to an object. Frequent adjectives such as light, medium, or heavy are used to remove some of the vagrancies concerning the strength of the applied force. Pressure measurement. When used with the technical sense, the pressure defined with the amount of the force per unit or universal, consistent, definite, meaning standards and measurements of are used to be expressed. Pressure in the United States, the pound is the unit of the measurement used for force, and the square inch is the unit of the area. The comparable unit for the measurement used in speed is the mile unit, and the measure of distance, and the hour is the measurement of time. A pressure measurement is always expressed in terms both of units measurement, just to explain the amount of force in the unit area. However, the one of these units of the amount of force is variable. The square inch is used only in a singular, never more than less than 1 square inch. Given pressure measurement can be stated in 3 different ways, still meaning the same thing. Therefore, 50 psi pressure, pounds per square inch, 50 pounds of pressure, and 50 psi also have the identical meanings. Example, pressure measurement. A table within 10 inches by 10 inch flat top containing 100 square inches with the surface of a 100 pound slab with exactly the same dimensions placed on the top of the table, on the tabletop. 1 pound square inch and pressure exerted on the entire table surface known as the same. Think of the same table as 100 square inches with a 100 pound block instead of a slab resisting on the top, assuming that the block of the face is only 50 square inches contact table, because the area contact has been cut in half. The weight of the block remains the same. The pressure exerted on the table doubles by 2 psi. As final example, suppose a long rod weighing 100 pounds weight with a face of 1 square inch is based upright on the top of the tabletop. Pressure now being exerted on the table is increased to 100 psi. The square entire load is being supported on the single square inch of the table surface. These examples are illustrated in Figure 1.1. Force areas pressure formula. From the preceding discussion, you can see the formula to find the pressure acting on the surface is pressure equals force divided by area. If P is the symbol for pressure and A is the symbol for area and F is the symbol for force, the formula can be expressed as follows. Alright, P equals A over E over A, the transposing symbol of the formula of the 2 other important formulas divided, one from area for one for force, respectively. Our area equals force over pressure. However, using any of these following 2 factors must be known to be able to determine the third unknown factor. Alright, Figure 1.1 shows the measurement paper of a 10 by 10 square sheet of over 100 that holds 100 piece of slab and a 100 pound rod. Figure C. The triangle shown in Figure 1-2 is the coefficient memory device for the force of area performance, pressure performance that helps you recall the three factors involved, F, A, and P. Because the F is above the line in the triangle, it reminds that both of the triangle formulas indicate division, indicating division. If this is always divided by one or the other two factors. Relationship with the force, area, and pressure. Triangle. Transmission force, two meaning the transmitting force through the solids and through liquids, since the text of the hydraulics emphasizes on the liquid for the transmissions through solids and presented only on the means of the comparison. The transmission force through solids force is applied on one point when on a solid body and follows in the straight line undiminished and to an opposite point of the body. The figure is illustrated in Figure 1-3. Transmission of force through the confined liquids applied with the force for the transmitted through the body for the confined liquids is the manner prescribed in Pascal's law of the laws of physics formulated in the 17th century by a French mathematician. Blaise Pascal states that pressure applied to any part of the confined liquid transmitted without any change to intensity of all the parts of the liquid. This means that whatever is applied on the body of the liquid pressure pushes equal force against every square inch of the interior surface of the liquid's container. When pressure is applied to the liquid container in its no down direction, it will not act on the bottom surface, but on the sides and top as well. 1-3 shows the transmission force through solids. Illustration Figure 1-4 helps to better understand the explanation of the piston of the top of the tube driven downward with a force of 100 psi. The applied procedure produces identical pressure for 100 psi with every square inch of the interior surface. Note that the pressure of the interior surface is always applied with the right angle to the wall of the container, regardless of the shape. That can be seen with the forces acting with the body with the confined liquid of the explosive bin pattern. If all the sides are equal in strength, they will burst simultaneously if insufficient force is applied. Figure 1-4 shows the transmission of force through confined liquids. 100 pounds of force through spreading upon the liquid in every outer interior surface. Characteristics of the fluid, the various difference in the manner with which the force is transmitted through the confined liquids is compared with the solid body due to the physical characteristics of the fluid, namely shape, the compressibility. Liquids have no definite shape. They will readily instantly conform to the form of the container because of the characteristics of the entire body, but the confined liquid tends to move away from the point of the initial force with all the directions until it stops in something of the solid such as the wall and its container. Liquids are relatively incompressible. That is that they can only be compressed by the approximately 1% of the volume because the liquid lacks their own shape. The incompressible applied with the force of the transmitted through the body of liquid confined with a rigid container results in no more per compression than if it were transmitted through solid metal. Movement of the fluid under pressure forces are applied with the confined liquid that can cause the liquid to move only when the force exceeds any other force of the liquid opposing on the direction. Fluid flows always in the direction of the lowest pressure if the opposing forces are equal. No movement of the fluid takes place, and the fluid under the pressure can flow in already inflated containers only if they equal greater or the quantities simultaneously flow out of them, and the obviously simple principles are but one that is easily overlooked. Effects of the temperature of liquid, as in metal, the temperature changes that produce the change of the size of the body of the water liquid, with the exception of the water. Whenever the temperature of the body of the liquid falls, a decrease of contraction in the side of the body of the liquid takes place. The amount of contraction and slight will take place in the direct with the proportion of the change in temperature. With the temperature rise of the body of the liquid expands. This is referred to as thermal expansion. The amount of the expansion is direct proportion to the rise in temperature, although the rate of the expansion relatively small is important. Some of the provisions usually necessary in a hydraulic system to accommodate the increases in size of the body of the liquid when temperature rises occurs. Mechanical advantage. By simple definition, mechanical advantage will equal the ratio of the force of the resistance overcome by the application of lesser force or effort. For the simple machine, this represents the method of multiplying force. Mechanical advantage of the gain of the force of obtained by the expansion of the loss of distance and the frictional loss of the percentage gain by the force of the equal to the percentage loss in distance. Two familiar applications for the principal mechanical advantages are lever and hydraulic jack. In the case of the jack, of force just as a pound or two applied to the jack handle can raise many of hundreds of pounds loaded. Note that each type of the handle is moved several times. The load is raised only a fraction of an inch. Application of hydraulics. The principle used for the hydraulics developed mechanical advantage and simple. Essentially is obtained by fitting two movable surfaces of different size with the combined with the vessel, such as piston and with cylinders. The vessel is filled with liquid and force is applied to the small surface of pressure is taken to transfer and means of the fluid into the larger surface where the proportional force output is produced. Rate. The rate of mechanical advantage produced by the hydraulic means with the direct proportion of the ratio of the size of the smaller input area, the size of the larger output area. Thus 10 pounds of force applied with the 1 square inch of the surface of of the confined liquid produces 100 pounds of force on the movable surface of 10 square inches. This is illustrated in Figure 1.5 with the increase of the force not free, but is obtained with the expense for the distance, and the expense for the tenfold increase output force is gained with the expense for the tenfold increase in the distance over which the initial force is applied. 1.5 shows the hydraulic and mechanical advantages of the 10 applied forces in the cylinder and the delivered force space and the delivered space of the piston. The role of air in hydraulics. Some hydraulic components require air as well as the hydraulic oil for the operation. Other hydraulic components do not. Instead of their performance is seriously impaired, air accidentally leaks into the system. Familiarization with the basic principle of pneumatics, understanding the operation of both the hydraulic components requiring as well as those that do not, and aid and also in the understanding of how air can upset the normal operation of a hydraulic system is present with the system where it must be air. When used with the reference hydraulics, it is understood with the meaning of the atmospheric air. Briefly, air is defined with a complex and indefinite mixture of the animated gases. Other individual gases may make the atmospheric air. 90% or more is oxygen, nitrogen. Some knowledge of the physical character of the air is quite important to the instruction because of the physical properties of all of the gases, including the air. At the same time, study of these properties is made with the reference of the gases in general. It is important to realize, however, the similar physical characteristics of the gases differ greatly with the individual chemical composition. This difference makes some of the gases extremely dangerous when under pressure. When they come to contact with certain substances, air and pure nitrogen are inert gases and are safe and suitable for use for the hydraulic system. Alright, caution, only air and the pure nitrogen authorized for use for the Army aircraft hydraulic system are related with the hydraulic equipment. TO-11312 uses high pressure air with the nitrogen L aircraft. Under no circumstances can any of the other gases be used since the disastrous explosion also must certain to result. Beware especially of the oxygen and of the silicane. Most frequently, the air used for the hydraulic system is drawn out with the atmosphere force for the hydraulic system means for the air with the compressor of the pure nitrogen. However, the available to use for the compressed bottle of gas. Application of the hydraulic. The ability for the gas to act with the management of the spring important into the hydraulic. The characteristic used for the hydraulic system and enable the system to absorb, store, and release the fluid energy required. The abilities with the system are often provided by the means of a signal component designed to produce a spring-like action. In most cases, such components to air, even though the spring might be equally suitable for the performance standpoint. Air is superior with the spring back of its low point because if it's not subject to the failure of the metal fatigue as a spring. The most common use of the air in hydraulic is found with the accumulators and shock struts. Malfunctions caused by air in general, all component systems that do not require gases in their operation are to some extent impaired with the presence of air. Example, the excessive feedback of loud noises from flight controls during operation, the failure of the wheels, rotor, or brakes to hold the manufacturer. These malfunctions can be readily corrected with the bleeding of the system and control wave, allowing the air to escape. The process examined in detail in the -20 TMs is particular aircraft involved. Fluids used in hydraulics. Two general types of the fluids can be used for the operation maintenance for the hydraulic system equipment: the vegetable base and mineral base. Although both types of fluids possible characteristics suitable hydraulic use, they are not interchangeable nor are they compatible as mixtures. As present, only mineral based fluids are used for the maintenance and operation of the hydraulic system. Self-contained hydraulic components of the Army aircraft, despite the vegetable base hydraulics, cannot be left entirely out of the discussion. In the past, some of the Army aircraft has been used vegetable based fluids hydraulic systems maintenance operation, also known as brake system automotive vehicles, and currently being operated within the vegetable-based fluid. It is quite possible that the supply of the type of the fluid may be erroneous and fall into the aviation supply system. Therefore, maintenance personnel must be familiar with both types of fluid so they can recognize the error with avoid the improper fluid. Moreover, the knowledge of the effects used for the improper fluid, corrective action to take and occur is an important knowledge of the system itself. Rubber parts and hydraulic part systems are particularly sensitive to the incorrect fluids. The rubber parts used in the system operating with a vegetable-based fluid are made of natural rubber. These operating with mineral-based fluids are made of synthetic rubber. Both types of rubber are seriously damaged by contact with the wrong type of fluid. Vegetable-based hydraulic fluids. So vegetable-based hydraulic fluids are composed essentially of the castor oil or alcohol. These liquids have easily recognizable pungent odor suggestive of their alcohol content. These are two types of vegetable-based hydraulic fluids that are aviation personnel can be issued in aircraft and automotive type. Their description is follows. The aircraft vegetable-based fluid is colored with the blue dye and identification designed for the MLH 7644. The vegetable-based hydraulic fluid current used for the automotive hydraulic system in an amber in the color of the military, designed with the fluid MLF2111. Remember that neither of these fluids are acceptable for the use of the aircraft hydraulics or not to be used in hydraulic jacks and or aircraft ground handling equipment. Mineral-based hydraulic fluids. These three categories of mineral-based hydraulic fluids are used in the Army aviation today. Operational, preservative, and cleaning. Operational fluid during extreme cold weather. The operation of the fluid not using the aircraft hydraulic system and components of MIL H5606. Fluid is colored with the red dye for the identification of the very distinct color. Odor MIL H83282 is to used in components and systems prescribed in Technical Bulletin 55-1533-425. Preservative fluid. Preservative fluid contains a special corrosion inhibitive additive. This primary purpose is to fill the hydraulic components to protect against the corrosion during the shipping of the storage. Designation MIL H6083A. The preservative fluid is very similar to the operational fluid in viscosity and odor and color. Operational fluid MIL H5606 and preservative fluid MIL H6083A are compatible but not interchangeable. Therefore, when preparing to install components preserved with the 6083A as preservative fluid must be drained to the point before installation of the components were filled with the operating fluid. The preservative fluid 6083 needs to be flushed with 50606. When using the MIL H83282, the preservative must be flushed as prescribed in Technical Bulletin 55-1533-425. Our cleaning fluid, Technical Manual 55-1500-204-23-2, contains a list of authorized cleaning agents, details, and use for the hydraulic system components. Because of the constant improvement of the cleaning agents, change for the basic technical manual printed with the described necessary for the reasons always prefer to the current technical manual and its latest change for the authorized cleaning agent. The use for the tape of hydraulic system components in the tables of fluid use for the following tables is a brief summary of the permissible use of the mineral-based hydraulic fluids. Table 1, use the mineral-based hydraulic fluids. Operation system of the self-contained units, fluid flushing, reassembled system, flushing and assembled individual components, preserving individual components, and washing seals. Washing parts except rubber parts and disassembled components. Corrective action following the improper surfacing. If the hydraulic system of the component is air and is surfaced with a vegetable base on fluid, the system must be drained immediately with the flush with lacquer thinner with military specification MT. MIL T6094A. The following components for the system must be removed as disassembled with the extent necessary to remove all the seals, components, and or wash seals and replace the new ones. The system is reassembled for the return of operation. Hot handling fluids. Trouble-free operation of the hydraulic system depends largely on the efforts to ensure the pure hydraulic fluid clean liquid system. The bulk container of the fluid must be carefully opened, completely closed immediately after dispensing any of the fluid. Dispensing unused fluid remaining in gallon and quarts containers must be disposed in accordance to TM 10-1101. Dispensing equipment must be absolutely clean. During use, filter plugs and caps of the bosses in which they are installed must be carefully clean before the removal of the dispensing of the fluids. Beside the take of the precaution with the dispensing hydraulic fluids are most to ensure the safety of storage of the fluids, observation and safety regulation, and fluid handlers. Fire hazards. Hydraulic fluids are quite flammable, most to be kept away from the open flames and spark objects with heat in the head at the high temperatures. Fluid leaks from the aircraft that define without fire hazard must be constantly looked at as promptly with the correct. The flash point of MIL H5606 is 275 degrees Fahrenheit. Because MIL H583282 has a flash point of 400 degrees Fahrenheit, it is safer to use than replacing MIL H5066. Although the two fluids are compatible, care must be taken to make sure of the two types has a volume no more than 3% of the MIL H5066. The mixture with a volume more than 3% MIL H5066. 5606 degrades the flash point of MIL H83282. The regulations storing hydraulic fluids are the same as those of the petroleum lubrication products. Enforcement is equally important to toxicity. Hydraulic fluids are not violently poisonous, but they are toxic to an extent. Unnecessary breathing of the fumes or prolonged contact with the quantities of fluid with bare skin must be avoided. Summary. Hydraulics and the use of the fluid under the pressure transmitting forth in the Army aviation. Hydraulics is used for the operator of the retraceable lading of the gear brakes in the flight, control the proper pitch for the loading ramp. The characteristics of the hydraulic system are efficiently dependable and dependability, control, sensitivity, flexibility for the installation, low space requirements, lightweight, self-lubrication, low maintenance requirements. Hydraulics operate on the principle of force and pressure. The unit measurement of the force in pounds, the air, the pressure, and the squaring the force of the pressure and measurement is expressed in pounds pounds per square inch, or psi, for the forces transmitted through the confined liquids without changing the intensity to all the parts of the liquid. Mechanical advantage is equal to the ratio of the force, or restrictive to overcome the application of lesser force for the even effort through a simple machine, getting the force obtained with the expense of the loss of the distance, the rate of the mechanical advantage of the reproduced. The hydraulic means for the direct portion of the ratio of size of the smaller input area with the size and larger output area. Some hydraulic components like shock struts and accumulators require air with a hydraulic fluid of their operation. Atmospheric air, pure nitrogen are the only gases authorized in U.S. Army aircraft. Only mineral-based hydraulic fluids are authorized for the use of the aircraft hydraulic system. Operating fluid MIL H83282 is replacing MIL H5606. Preservative fluid MIL H6083A. Care must be taken to ensure the contamination is allowed to enter the hydraulic system. And hydraulic fluids are quite flammable and must be handled and stored with the same precautions as petroleum products. Lesson 2: Hydraulic plumbing.